videos.
Right. So, let's try this. Let's find the major and minor axis of one is x squared over 2 squared plus y squared over 3 squared. Really this boils down to what's the closest that points on this thing get to 0 and what's the furthest away, right? You guys see that? Okay, so I really am looking to maximize this radius of x and y function, right? So what's the radius of a point xy? Yeah, so
X squared over 2 squared plus 1 squared.
no, don't be that. How far is xy from 0?
2 and 3.
Was it
X.
1? 1 squared?
I haven't done this since like
Square root
trig.
of x squared plus y squared.
Okay, forget that it's an ellipse. Here's a point, xy.
Yeah.
How far is this from 0?
I was thinking X square squared. root of x squared plus y squared.
Square root of x squared plus y squared, right?
Oh yeah.
Okay, let me forget the square root, and I'll just maximize x squared plus y squared, and that'll be fine.
So what's our constraint?
So the constraint is that guy, right? So I've got this ellipse that's my constraint, and then I'm trying to maximize the radius squared function. You guys see that? Okay, so Lagrange multiplier says I should just take the gradients of the bits here and set them equal with some constant. So what's the gradient of r? Two x and 2y. Okay. And let me call that something. I'm going to call this k of x and y, right? For constraint. Or to match the notation I was using a second ago, I would call it g, right? So what's the gradient of k?
Nightmares.
Yeah.
No, 1/4 or 1/2.
So 2x over 4 and 2y over 9, right? And I'm supposed to set these equal to each other with some lambda in them, right? You guys see that? So I'm supposed to say, okay, 2x is lambda
2x over 4.
2x over 4,
Or 1.
and 2y is
Lambda 2y over 9.
lambda 2y over 9, right? You guys see this? Okay. When do these equations simultaneously solve?
So will we
So it should be solving, right? So at the very least I can cancel some 2's right off the bat, yeah? Okay, so out of this one I got x is lambda over 4x. What's that tell you about x? Okay, so either lambda is 4, right?
Oh.
Or
x is 0.
x is 0. You guys see that?
But I thought.
But the other one, right? I got y is lambda over 9y, right? So what does that one tell you?
Either lambda is 9 or y is 0.
Either lambda is 9 or y is 0.
Seeing how lambda
Guys see that?
counted two different numbers.
You see that? So there's only two options, right? Either lambda is 4 and y is 0, or lambda is 9 and x is 0. You see that? I don't give a crap what lambda is. So either x is 0 or y is 0. Cool?
Check.
Yeah, and then I should Well, those are x values and y values, right? That's not the point 0, 0. You see that? So I'm looking at either x is 0 or y is 0. What's the corresponding, like what's the y for x is 0?
Get that from our constraint.
Yeah, you get that out of your constraint, right? So when I plug x is 0 into the constraint, yeah, I get y is plus or minus 3. And when y is 0, x is plus or minus 2.
What about the 1? Right?
Yeah, what about the... Is the
Because
constraints equal to 1?
Mm-hmm.
Yeah, but if you plug in 0 for x, you get y squared over 3 squared. And you
Equals
multiply
1.
both sides
Oh yeah,
by 9.
multiply.
So 1 is y squared over 3
yeah.
squared.
I was adding it.
Okay, cool. Alright, so these are the points, right, that are either maxes or mins for my r squared. You guys see that? Okay, so which one's which?
Plug them in and compare the function.
Yeah, plug them in and compare, right? So if I plug in 0 and plus or minus 2 to this, I get 4 out. If I plug in 0 and plus or minus 3, I get 9 out, right? So this is your max, and that is your min. What's that tell you about axes? Good. The major axis is length 3 and it's in the y's, and the minor axis is length 2 and it's in the x's. You guys see that? Okay, you want to see the level curve picture? That was kind of why I picked this one. So there's nice level curves. So the level curves here are all two-dimensional. I've got a constraint that looks like an ellipse, right? And now I know that the minor axis is in the x and the major axis is in the y.
Hang on, can you go back? Why is that?
Yeah.
Oh, just kidding. I wrote it down wrong.
Okay. So here's your really crummy drawing of an ellipse, right? And if I start drawing circles in this thing, right, like here's a circle, here's a circle. Those are really crappy circles. Worst circle ever. How about there's a circle? And then when's the first time it touches that ellipse? Yeah, when it's radius 2, right? When it looks like this. Yeah, see that? That's the gradient vector of the green and the gradient vector of the black lining up, right? And then if I keep increasing circles, I've got 3 points on that, or 4 points on that level curve. Maybe 4 points on that level curve. You guys see that?
Those are intersections, but they don't line up.
Yeah, they don't line up, right? I can do better, right, by just moving a little bit out on the constraint. So the last point, right, where I get that maximum radius is when those things are parallel again, right, and it just barely kisses. You guys see that? Right, so the constraint is going to be, it's going to be tangent to a level curve the first time it hits and the last time it hits, and that's it. Yeah, almost. Those are the ones you're going to want to check anyway, right? So in this case, we found our max and min pretty much right away. But you have to be a little careful, right? Simultaneously solving a couple equations is a little bit funky, especially when there's that lambda in there. It works best if you try to get the lambda out of everything so you don't have to figure out what it is.